Hello everyone, welcome back with another lesson of our DSA lesson series, and today we're going to talk about dynamic programming. Many students feel that dynamic programming is difficult, but trust me, once you understand the idea behind it, it becomes much simpler. So in this video, we will cover what is dynamic programming, why we use it, overlapping subproblems and optimal substructure, and a simple example using Fibonacci sequence, and finally, how this dynamic programming is different from normal recursion. So let's get started. So when we are talking about this dynamic programming approach, it is a technique which is used to solve complex problems by breaking them down into smaller subproblems. And instead of solving the same subproblem again and again, what this dynamic programming approach does is that it solves each subproblem once and stores the result, so it can be reused later. So as the purpose of using this dynamic programming is to reduce time complexity, avoid repeated calculations, and also to make algorithms more efficient. In simpler words, this dynamic programming is about working smarter, not harder. Now let's understand the key concept of this dynamic programming, which is overlapping subproblems. A problem has overlapping subproblems if the same smaller problem gets solved multiple times. So imagine we solving Fibonacci 5. To solve Fibonacci 5, we need Fibonacci 4 and Fibonacci 3. But to solve Fibonacci 4, we again need Fibonacci 3 and Fibonacci 2. Here you can see that Fibonacci 3 is getting calculated more than once. So this repetition is called as overlapping subproblems. But in dynamic programming, it avoids this phenomenon by storing the result of Fibonacci 5 the first time it gets calculated and reusing it later. The second concept we are going to look into is optimal substructure. A problem has optimal substructure if the optimal solutions of a problem can be built from optimal solutions of its subproblems. So for example, to solve Fibonacci 5, we need Fibonacci 4 and Fibonacci 3. But if Fibonacci 4 and Fibonacci 3 is solved correctly, Fibonacci 5 will also be correct. So this property of dynamic programming allows it to build solutions step by step from smaller answers. Now let's properly understand dynamic programming using the Fibonacci sequence step by step. The Fibonacci sequence is a simple number series that starts as 0, 1, 1, 2 and so on, where each number is the sum of previous two numbers. So here you can see 0 and 1 equals 1, 1 and 1 equals 2, 1 and 2 equals 3, 3 and 2 equals 5, likewise. So formally Fibonacci of 0 is 0 and Fibonacci of 1 is 1, and for any other number n, Fibonacci of n is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. Let's say we want to calculate Fibonacci of 5 using normal recursion. According to the formula, Fibonacci of 5 becomes Fibonacci of 4 plus Fibonacci of 3. Alright, so when we expand this further, Fibonacci of 4 again breaks into Fibonacci of 3 plus Fibonacci of 2, and Fibonacci of 3 breaks into Fibonacci of 2 plus Fibonacci of 1. Right, so here you can clearly see that values like Fibonacci of 3 and Fibonacci of 2 are being calculated multiple times. If we draw the recursion tree like this, Fibonacci of 3 appears twice right here, and Fibonacci of 2 appears twice right here. So this repeated calculation is the main drawback of recursion. For small values, this does not seem like a big issue, but when the input becomes large, such as Fibonacci 40, thousands of unnecessary functions cause making the program very slow and causing the time complexity to grow exponentially. This is where the idea of dynamic programming comes in. Instead of recalculating the same Fibonacci values again and again, dynamic programming asks a simple question. If a value has already been computed once, why compute it again, right? The solution is to calculate each Fibonacci number only once, store the result and reuse it whenever needed. In practice, we do this by using an array. So here we first create an array, then what we do is that we store dp0 as 0 and dp1 as 1, and then build the solution from bottom up. Using this approach, dp2 becomes 1, dp3 becomes 2, dp4 becomes 3, dp5 becomes 5. Each Fibonacci value is computed only one time. There is no repetition, and the recursion tree problem completely disappears. As a result, the time complexity is reduced from an exponential big O 2 to the power n in the recursive approach to the linear big O n in dynamic programming, which shows dynamic programming turns a slow solution into a fast and efficient one. Now let's talk about the difference between recursion and dynamic programming. So both of these two solves problem by breaking them into small subproblems, but they differ in efficiency. In recursion, the same subproblem can be solved multiple times, which leads to repeated calculations and slower performance for larger inputs. Dynamic programming improves this by storing the result of solved subproblems and reusing them, which avoids repetition. While recursion is simpler and easier to write, dynamic programming is fast and more efficient, especially for problems with overlapping subproblems. In short, recursion focuses on the problem structure, whereas dynamic programming focuses on optimization. I hope you all got a clear understanding about today's lesson, dynamic programming. So if you find this video valuable, like, share, subscribe and click the bell icon to be notified. Thanks for watching.